This is a video from my Math 386 class. The directions say to evaluate each function for the given values. Let's take a look at example 1. Suppose I'm given f of x equals 6 minus 2x. In part A, I want to find f of 3. So wherever I see an x, right, I'm going to replace it with 3, which I will put in blue. So in order of operations, right, we have to take 2 times 3 first. And so this is 6 minus 6, which is equal to 0. In B, suppose I had f of negative 2. So wherever I see an x, I'm going to replace it with negative 2. So this is 6 minus 2 times negative 2. But this is equal to 6 plus 4 because negative 2 times negative 2 is positive 4. And then 6 plus 4 is 10. So that's part B. Now, let's take a look at part C. F of negative 12.7. Wherever I see an x, I'm going to replace it with negative 12.7. So this is 6 minus 2 times negative 12.7. Okay? And so this is 6. A negative times a negative is a positive. So this is plus, and then we're going to get 25.4, I claim. So the correct answer here is 31.4. And then lastly, on D, suppose I had f evaluated at 2/3. Wherever I see an x, I'm going to replace it with 2/3, okay? And so this is 6 over 1 minus 4/3. But isn't the LCD, the lowest common denominator, 3? And so I got to take the first number and rewrite it with a 3 in the denominator, okay? And so this is 18 divided by 3 minus 4/3. And so the correct answer here is 14/3. And that's how we do example 1. And with that, let's take a look at example 2. Suppose I had R of S equals 2s minus s squared. And then I want A. Suppose I want R of 2. Wherever I see an S, I'm going to replace it with 2. So I get 2 times 2 minus, and then I'm going to take 2 and raise it to the second power. Okay, because remember, wherever I see an S, I'm popping that 2 in. Now, 2 squared is 4, and 2 times 2 is 4, right? So this is 4 minus 4, which is equal to 0. If we take a look at B, okay, so this is R evaluated at negative 4. So wherever I see an S, I'm going to replace it with negative 4. So I take 2 times negative 4, and I'm going to subtract off negative 4 raised to the second. Okay? Now, 2 times negative 4, that's negative 8. And then if I take negative 4 and square it, I get 16. And you guys have a calculator, right? negative 8 minus 16 ends up being negative 24, like so. On C, suppose I want r of a third. Wherever I see an s, I'm going to replace it with 1/3. So I get 2 times a third minus, and then I'm going to take 1/3 to the second. So this is 2/3, right? If I take 1/3 and double it, I get 2/3. And then I'm going to subtract off 1/9. But isn't the LCD between 3 and 9, 9? And so what I want to do is build 2/3 up to have a 9 in the bottom, which means I have to multiply the numerator and denominator by 3. Okay, because 3 over 3 is 1. Anytime you multiply by 1, the number doesn't change. So this is 6 over 9 minus 1/9. And so therefore, to give myself a little room, r of a third, right, is going to equal 5/9. And that's how we do C. Let's take a look at D. Suppose I had r of negative 1.3, right? So wherever I see an s, I'm going to put in negative 1.3. So this is 2 times negative 1.3. And then I'm going to subtract off, in parentheses, negative 1.3 squared. So we have to remember our order of operations. We have to square out that negative 1.3 first and then attach a negative. So on the very next line, I'm going to get negative 2.6. That's if I double 1.3. And I'm going to subtract off 1.69. So I'm very old school. So I'm going to take 2.60 and I'm going to add up 1.69. And when I add those, I should come up with 4.29. So I think about it like money. And so since they're both negative, I lost that much money. And so therefore, r of negative 1.3 is negative 4.29. And this is example 2, right? So if you look, we did the 4 parts. Let's do another problem here. So if I give you this one, we'll call this example 3. So I'll call this f of x, capital F of x, is 1 minus x divided by 2x minus 3. And in A, I want f of 0. So wherever I see an x, I replace it with 0. Okay? So I get 1 minus 0 in the numerator. I get 2 times 0 minus 3 in the denominator. So in the numerator, I get 1. In the denominator, I get negative 3. So f of 0 is negative 1/3. So on B, what if I had f of negative 3? So wherever I see an x in open parentheses, those parentheses, I'm going to replace x with negative 3. It is very helpful to place parentheses appropriately. And I'm going to divide by 2 times negative 3, and then I'm going to subtract 3. So this is 1 plus 3 divided by negative 6 minus 3, which is negative 4/9. So therefore, f of negative 3 is negative 4/9. That's B. We could try C, right? So suppose I had f of 5/2. So wherever I see an x, I'm going to plug in 5/2. And then I'm going to divide by 2 times 5/2, right? Minus 3. So this one's really, really, really very interesting, okay? Now, if we look at the denominator, notice how the 2's cancel. And in the numerator, I get 1 minus 5/2. In the denominator, I get 5 minus 3. Okay? Now, from here, this is 1 minus 5/2 divided by 2. So I'm going to multiply the numerator and denominator by 2 divided by 2. And so f of 5/2. Now, 2 times 2 is 4, okay? If I distribute the 2, 2 times 1 is 2, and then 2 times 5/2, if I double 5/2, I get 5, which is negative 3/4. So, therefore, f of 5/2 is negative 3/4. And then on D, f of 9.8. So you get 1 minus 9.8 divided by 2 times 9.8 minus 3. Let me write that again. So I get 2 times 9.8 minus 3. On top, right, I'm going to get negative 8.8. In the denominator, right, I'm going to get 19.6 minus 3. So you get negative 8.8 divided by 16.6. Now, if I multiply the numerator and denominator by 10, that's going to cause a shift of that decimal one place to the right. That's how that works. And so f of 9.8 is negative 88 divided by 166. Well, can I divide numerator and denominator by 2? And in fact, I can. And when I do that, I get negative 44 in the numerator. I get 83 in the denominator. And so, therefore, f of 9.8 is negative 44 over 83. And that's how we do example 3. Let's take a look at one more example for this video. Suppose I had e of x is the square root of x minus 4. A. What is e of 16? So wherever I see an x, I'm going to plug in 16. But isn't 16 minus 4 12? Right? Now, remember, I can take the square root of 4 nicely. And remember, 4 goes into 12. So I'm going to write this as 4 times 3, right? So in other words, under the radical. So in other words, I'm going to take the square root of 12, and I'm going to write it as the square root of 4 times 3. But isn't the square root of 4 2? And so e of 16 is 2 multiplied by the square root of 3. That's A. Let's do B. E of 4. That's the square root of 4 minus 4. You must subtract 4 from 4 inside the radical first. So in other words, I expect to see this. So this is the square root of 0, which is equal to 0. And so, therefore, E of 4 is 0. And then I'm going to do E of 7. Wherever I see an X, I'm going to plug in a 7. And so we get the square root of 3. So E of 7 is the square root of 3. And then last one, E of 4.2. That's the square root of 4.2 minus 4, which is the square root of 0.2. There's not a lot you can do with that, to be honest with you, because I can write this as the square root of 1/5, right? Turns out that 0.2 and 1 over 5 are the same. But isn't the square root of 1, 1? And so the only thing you can really do here is call E of 4.2 1 divided by square root of 5. And that's okay, right? It works. And this is example 4. And that's a good stopping point for this video. This is a video from Math 386 exam review. And it's evaluating functions for specific values of x. Thank you.